everyone.
Good morning, Sage. I think we lost some people with the meeting changes. Hopefully, I'll post something next week on Ceph Devel. Try to get people back.
I'm going to remove this project folks are working on. This is all totally old as far as I can.
Yeah, sounds like a reasonable idea.
All right. 27th. Dun, dun, dun. All right. So there are a couple new requests. There's one that adds discard. There are a bunch of problems with it, if I remember correctly, as far as how it's implemented. But that also begs the question of whether we should be doing discard. We would need a config option to turn on and off because some SSCs still don't want you to do it, and it tends to be slow in many cases. For now, we're just not doing it at all. I seem to remember a conversation with Alan where we decided it wasn't even worth doing at this stage, but I can't remember exactly what the reasoning there was. That was a while ago. But yeah, that probably needs to be revisited. The adaptive throttle is there. I think it's not, the good news is it's not having a big performance impact. I suspect that's because it's not actually really throttling anything without it being sort of tuned carefully. So I'm not sure that actually helps it's doing anything useful. So I need to sort that out still. Let's see, so we adjusted the throttle cost function a little bit so that it works better for small IOs on hard disks. That got changed. The other pull request that cleans up the throttle options, I think, is either ready to merge or merged already. I can't remember if it merged yet. Anyway, it's close. Let's see, there was a FIMAP change that fixed some encoding that got merged. That's just avoiding some wasted CPU when doing sparse reads. There's a BlueStore change that makes it not check the free space for BlueFS on every single commit cycle. That showed up in the wall clock profile. That got merged. There's a Cephfs change that I don't know anything about. That merged. There was a really old change to buffer list that avoids a copy. That got merged. A KStore change that got merged. KStore isn't really used by anybody, so that doesn't really matter, I don't think. Tiny optimization to pg.cc that changed, and we closed some Jean Peng was adding some perf counters, so we closed that. I guess decided it wasn't worthwhile. A couple other things are still in flight. There's reducing some of the lock acquisition. Needs a test to go through testing. The sync write change still needs to go through testing. This is the idea here is to reduce the latency, to reduce the number of context switches in the KV sync path. Most of the writes through BlueFS, through RocksDB, are blocking anyway, because it's a compaction thread that's doing a write and then calling fsync, or it's the KV sync thread where it's doing a write and then calling fsync on it. So the idea is to just do a ODirect write without doing a context switch, instead of scheduling an AIO, having it wake up on another completion thread and then wake up the calling thread that's blocking and so on. So I suspect that'll make a small difference on NVMe drives, but it's off by default, but the option's there now, so that can be played with. John Peng had a pull request that was combining op commit and op applied. That actually looked pretty good, but I think he submitted a new version that switches around so that the op apply just happens in the caller synchronously, since BlueStore doesn't actually need you to wait at all, and neither does MemStore. They both, as soon as you queue the transaction, its results are visible through the caching in the object store implementation. So I think that'll be simpler. That means that the up-applied callback is basically only used for file store, which is the only one that has this goofy, you have to wait until it gets journaled and then applied before you can read it again. So that'll eliminate a little bit of PG lock contention because there'll be one less callback that has to run. Let's see, the BlueFS thing needs more work. It failed QA again. Excuse me. The CRC one is being discussed. And I have a pull request that changes around the epic tagging on OSD to OSD messages to hopefully make the OSDs block less often. And that I rebased that yesterday, I think, and we reviewed it. I think it looks good. It just needs to be tested and then get a second review. That'll just eliminate sort of a bunch of random tail latencies basically in the OSD. And the other one that's not on this list is the deferred write handling, which I just rebased and needs to get scheduled for QA. So it's coming shortly. And that's it for the stuff that actually moved. I think all this other stuff is pretty stale right now. Not worth discussing. Any questions on those?
Yeah, sorry, the deferred write handling one wasn't in the list. I'm surprised I missed that.
It was, I just rebased it yesterday, so maybe you just didn't see the rebase. Doesn't matter. Yeah, hopefully it'll go through the QA suite today. Okay. So let's see what's on discussion topics. Before we start, this is stuff that Mark put on there. Is there anything else anybody wants to add to the list today? Okay. So throttling. Let's see, Mark did some testing to try to figure out if the throttle, the constants used for hard disk and for SSD to calculate a cost per operation were actually correct. Because I sort of just pulled them out of my butt beforehand. And he came up with some better numbers and reversed them. That's the version.
Yeah, better is a strong word, I think. But
yeah.
I don't know. I kind of still wonder if there's a way to have, if it's not even real time, but have something like a tool that can be run when the OSD is set up that can go through and just basically do what I did automatically. Put it in Google Drive.
Right. I think, yeah, probably in sort of an isolated where you're running a specific set of operations to try to understand the device, you could do that, but I don't know that we can do it under load. Well, okay, so a bit of background here. This is based on the unified throttle stuff. So the idea is that it used to be that we had a throttle for the number of bytes that are in flight, and then we also had a separate throttle for the number of operations that are in flight, and they were just sort of set mostly arbitrarily. And so you got two throttles that were one or the other might be kick in. And so the unified one just makes defines a new cost function for each operation as a function of the number of bytes and the number of IOs that operation includes, and then defines a really simple cost function based on those two inputs. That's a linear combination of them. And then that cost function is then applied to a single throttle. So in reality, it's just the number of bytes plus some multiple times the number of IOs, and that multiplier changes if it's an SSD or an HDD because Seeks are more expensive on a hard disk. And so it's just a matter of picking that multiple. And then the throttle is set sort of in units of megabytes, more or less. And so the idea is to run a large write workload and then adjust the throttle so that it's at the lowest value that still gets you almost all the throughput. So we have the shallowest queue that still lets us fully utilize the device. And that seems to be around 64 megabytes, roughly, at least on hard disk. I'm not sure that it matters on NVMe. And then for small I/O, we would do the same thing where we leave the throttle where it is, run small I/O, and then adjust the multiplier so that effectively you start throttling the small IOs with larger multipliers. And again, get to the point where it's the largest value and thus the most throttled that still gets you most of the throughput of the device. And that's the sort of the shallowest queue depth, I guess, within BlueStorm. So that's what that document does, basically. And the value for hard disk ended up being 1.5 megs per IO. That seemed to work. What was the, actually, let me look at that again. What was the queue depth?
16.
Okay, I wonder if that was obscuring something, because if you have a higher queue depth, if you have 128 IOs that's standing in the OSD and the OSD is batching more of those, then it might get better throughput. You know what I mean?
Mm-hmm. Sure.
We might have missed something there, because you would expect that doing more than 16 4K IOs per commit cycle would be much faster. You know what I mean?
Maybe. And do you think that, how much faster are you thinking?
Well, the fact that there are only 16 IOs available to the OSD at all means there's a ceiling on the amount of batching that we were able to do.
Yeah, fair enough.
So, I mean, in theory, if you had 1,000 IOs and you had CPUs infinitely cheap, then you would do all 1,000 at a time, and you'd get like whatever that is, 40 megs per second or whatever, or 4 megs per commit, which would be a lot, however many that is per second. So we probably need to go back actually and repeat that experiment, but with a deeper, make sure that you have multiple clients, or at least lots of clients with deeper queues, or at least one client with a much, much deeper queue or something, to make sure that there's plenty there.
Yeah, I guess, I mean, what I'm really concerned about is that it's just going to shift things around. Like, we're going to try this with different IO depths and different queue depths or other things, and we're going to see different kind of points at which we see that transition away from like the high tail latency. That's kind of what we're. State, you're muted, I think.
At some point it'll level off, though. At some point there will be some number of IOs per commit cycle that is all that it can handle.
Yeah.
Or sure. That actually keeps utilized. But yeah, I mean, in retrospect, I think we should probably revert that change, because 16 it definitely is not enough.
Oh, we can give it a try. See what it changes. Certainly.
Okay. Let's see. Okay. Anything else on throttling?
Well, any thoughts on why we saw that behavior on the SSD journal, or NVMe, not journal, while in DB, where we see the latency decrease and then like the tail latencies get much larger as we change the cost values? That still concerns me.
Not offhand, but given that the IO depth is only 16, I'm not sure that the numbers mean very much.
Okay.
My best guess is that it was getting into one of those cycles where it's doing one commit cycle where it does one IO, and then the next commit cycle it does 15, and it's flip-flopping back and forth. And maybe based on these throttles, it either settles into that sort of equilibrium state or an equilibrium state where it's like, 7, 9, 8, 8, whatever.
Mm-hmm.
And that makes you get this, either way, you get a bimodal distribution or whatever. And depending on how bimodal it is, you might have a higher tail latency. That's my only guess. But
that's not bad. I mean,
I wouldn't worry about it given that, with the limited queue depth, I don't think it means anything.
Okay.
Until, excuse me. Okay. And then there's more walk clock profiling with shallow.
No, this was something I was trying to submit to Ceph last week, and it apparently never went through, probably because of our random network issues at Red Hat. Sorry, that was actually yet another wall clock profile that I don't have there. But in this particular one, this is just doing 4K random writes. I think this was to master, maybe. I'll have to go back and look. But in the email to Ceph, I've got a bunch more information about what's kind of going on here. Let me pull it up.
I'm looking at this. I'm just searching for shallow copy, and I'm only seeing it 0.1%, which is like one sample point.
I didn't make this clear. That's actually a different one. That one was during 4 megabyte writes. The one that you're looking at is during 4 KB random writes. So I can also link to that one.
That makes sense. Yeah, it's probably doing a mem copy on a 4 meg buffer. That makes more sense. That's a little confused. That's why that was making a difference.
Yeah. And the one that I've... Oh, go ahead.
I was just going to say that the code in there is really weird. I don't understand why it's branched the way it... Basically, if the current pointer buffer segment has enough for the whole thing that we're copying out, then it does a shallow copy, which is what we want. It just adds a reference to it. But if it extends beyond that chunk, then it does a full copy. And that doesn't make any sense why it would do that. I have no idea why. I need to go look at the kit history and figure out how it ended up that way. But it looks pretty wrong. So I'm guessing that's just a change, but I need to just make sure that there's not some weird reason.
Yeah. Yeah. I mean, it's not really, really huge, but I mean, it looks like it was using like 9% of every TPOSD thread, TPOSD thread, something like that, whatever.
It's not insignificant.
Yeah. Okay, so this other one though, that's 4K random writes. In that one, there was a bunch of stuff that was kind of interesting. Probably the big thing, the first big thing that's in there in thread 2, like 95% of the time is spent in background call compaction, and like I think 70% of that is all spent doing random reads. So we're just spending lots and lots and lots of time doing random reads in compaction.
Yep. Which line are you on in here?
I've got so many different windows open right now. Just 1 second.
I don't know if ready is not on. So this is the thing I was hoping that somebody who works with RocksDB could dig into and understand. My guess is that RocksDB is using opening the file when it's doing compaction with the open for random read or whatever, as opposed to read sequential, which means that BlueFS isn't doing any prefetching. But I thought that compaction should be doing sequential reads. But maybe I'm just wrong. I don't know.
Sure.
Yeah, I just don't understand what compaction is doing here. So.
Yeah. So the first example of this is on like lines, well, like I guess 34 is I guess kind of where it goes down to. You can see that's one part of it. But then if you actually go to some other lines, you'll see more. There's like another 19% that's spent doing this.
Yeah.
Oh, starting at like line 96.
All over the place here.
Yeah, it's just I went through and actually kind of added it all up, and it's just it adds up to be a lot of it.
Yeah, I mean it kind of makes sense. If you're doing compaction, you're going to be the thing that you're actually consuming all the time is reading the data. So it's not like we're doing anything wrong necessarily, unless we could read it more efficiently. So I'm guessing that there might be an opportunity to do prefetching if we understood what the workload was. But you'll notice this first case on line 31, it's a random access file reader, and that's not what I thought it should be. But so everybody who's a manager on this call, if you have somebody who has RocksDB background or experience and has time to go do this, that would be extremely helpful, because we don't have anybody in Red Hat right now who has time to go understand what RocksDB is doing, or anybody else for that matter wants to go dig into this. That would be helpful. I don't think this isn't going to get fixed until somebody goes and understands what RocksDB is doing, and I don't have time. So it keeps coming up over and over again.
Yeah. All right, so let's move on then from RocksDB. Line 2179, that's thread 44, the bstore KV sync thread.
$21.44. Must be on the wrong file still.
2179.
Oh, sorry. Okay. Yep.
All right, so 38% in submit transaction sync. That's ultimately kind of mostly goes down to doing fsyncs.
Yep. So RocksDB is spending most of its time waiting for its I/O to reach the disk. So this is why I did that sync BlueFS sync read, because it's in wait for I/O. It's sitting there waiting to be woken up by another thread. And so the thought was that if we're not doing AIO, we're doing a synchronous write, that'll be one less context switch, and maybe that'll be a bit quicker. So after we sort the throttle thing out, that might be something to look at. Try that branch, the synchronous write branch or whatever, and see if this number goes down and the latency goes down.
The next line, 2356. We're in RocksDB store submit transaction.
And this is all CPU time. All right, this is just, is this small I/O or large I/O?
This is small I/O. Yep, this is 4K random writes. So here we can see there's some stuff doing write batch internal RocksDB, going through key comparisons. Yeah.
So I mean, it's keeping these keys sorted, I guess. So it's got a skip list. That's probably the slow part.
Yeah.
If I had to guess, I would say that my guess would be that if you take the write buffer and you make it not crazy huge, right now it's 256 megs, and you go back down to like 8 megs, which is what the default is, I think. Or is it 16 megs, something small? Then this will go way down. because that's 256 megs of tiny key value pairs that have to be sorted in memory. That turns into a big sorted data structure. Right.
It's true. It's very true. Although we seem to suffer for it in other ways. That's what.
Yeah, we did 6 months ago or whenever when we did that test.
It means we have a ton of more stuff that seems to get compacted if we do that. So we trade one mess for another.
It might be worth just trying it, just to see if this goes down, just to make sure we understand that's what it is and that's what the trade-off.
Sure.
What the trade-off is.
All right, let's see. We've got another small hot point. 2434. RocksDB log writer add record. And here we're doing, well, RocksDB is doing appends on their, this is Blue Rocks, right? Writable file append.
So 5% as a mem copy, 2% as a CRC. Looks like it's doing the fast CRC. I don't know if is that the CPU optimized one? Does anybody know? I know this got fixed recently, but
I don't remember, to be honest. I think it is, but I don't really remember.
Flash. So, yeah, the mem copy isn't going to change without significant effort. I guess the good part is that it's actually mostly mem copy and not the function call overhead that's being used. Looks like there's some lock contention on the flush call. And then a little bit of flush. Yep.
So let's see. Whenever you're ready, we can go to the next line.
Yep.
2494. Blue Store deferred try submit.
Yep. So 7% of that is in the IO submit syscall. That's not going to change.
And,
1% is shuffling all of the pointers around to make it aligned.
Okay, next is 2584. Dixie State Proc.
Which thread are we on again? This is KV sync thread?
Yeah, we are still in the KV sync thread.
Yes, that's where everything happens. Okay, so state proc, 6% is in cleanup, calling completion. So that's a lot of this is going to be crazy that the destructors take so much time.
I've got more destructors for you later. But anyway, yeah.
A lot of freeing up memory.
Yeah, in fact, speaking of OSR reap done, I'm pretty sure that's what I was looking at yesterday when I was looking at 4 megabyte writes that we were spending a bunch of time doing exactly this kind of stuff with deallocating or destructing trans context. I have to go back and look again, but I think this is popping up in a couple of different situations. Then beyond that,
this one, the finish right looks like a case where flat map or the collection slab allocator slab collection thing would help, because these are usually very small. and we're doing, all this stuff, hitting the allocator instead of doing it in a lockless way with the local allocation. I wonder if we should, that might be a good thing to keep track of, is if we can find multiple cases where these allocations are consuming a significant amount of time and they're small. So line 2757 here, there's the buffers for a blob, for a shared blob. That's usually one buffer or a very small number of buffers. So that's something where the slab collection thing that Alan prototyped would work well. Let's see, where's the others? These other piles of crap. Intrusive pointer. There are probably other ones here. There's more finish right. Right batch is, oh no, that's RocksDB. IO context, that might be a good one. It's a list of AIOs, but we could probably make it a vector and just say that, because we don't really care how much memory the trans contexts consume. It's like it's a per transaction structure.
Yep.
That's ephemeral. They're just sliding through, so we could, making it a linked list probably doesn't make a whole lot of sense.
How many are usually in that list?
It depends on how big the IO is. If I had to guess, it's anywhere from between like 4 and 20, but I don't really know. We could probably do some simple instrumentation to see how many AIOs happen per such requests.
Like you said, the linked list seems like it for that small of a data structure. The few number in that seems crazy.
Yeah. Yeah.
So let's see.
And I think it's sort of a double whammy too, because each AIOT also has a list in it, I believe, of the IOVEX, as it might be a scatter gather. So it's like it's a list of lists. So yeah.
Yay.
Yep.
Allocate and deallocate that constantly. Yay. Okay, maybe move on. We've got 2936, and this is the start of the piddly stuff that remains in KB sync thread here. So there's just some more various bits going on.
This is a map of it's a set of trans contexts. Yeah. Let's look at that.
So yeah, I mean there's some various things there, but maybe now move on to
I think Igor had this is removing it from flush transactions. I think Igor removed this because we weren't actually using it anymore.
I think that's on review.
Still. Yeah, under review. Yeah. Yep. So you gotta look at that carefully. It used to be really important, so I need to make sure you really don't need it anymore. Yeah, that would be helpful. Okay.
If we want to, we can move beyond that thread now to line 3079, which is where the finisher thread starts.
Yeah, so I think this is getting into stuff this is all the OSD work.
Sure.
So the good news here is that there's a bunch of time here that's spent in, where is it? Somewhere here we should see the PG lock pop up.
That was for sequential writes when we were.
Oh yeah, for random writes it doesn't get contended. Okay.
Yep, exactly.
Well, regardless, there's a pull request under line 3183, I think it is. Oh wait, maybe not. No, not op reply. It's the one wherever the applied callback basically is going to go away. So that will help some of this.
Okay.
This is. How long did you run this?
This probably ran for somewhere on about 2,000 samples. So this time period is probably over about a 15 to 20 minute period of time.
Okay, that's pretty detailed. Yeah. Anyway. Yep, and this is all stuff in the OSD.
Yeah,
yes, yes, I think some of it is possible. Yeah, I don't know.
There's this async connection send message, and underneath it looks like there's a lock that we're spending a fair amount of time in.
Mm-hmm.
3100, line 3100.
Yep.
And then let's see what else we got.
The op tracker comes up here. The fair amount of time spent there.
What line?
3388.
3388. Okay, I haven't done there yet. Before that one, were you saying, was it repop all applied that you were talking about earlier?
Yeah, but I'm not sure that that's the right one.
Oh, 3183.
I think that's all coming out of eval repop, and I think that's not the same callback I'm thinking.
Okay. We do have on 3279 2.5% in PG published stats to OSD.
Is that what is it doing? Yeah. It's probably doing that on every operation. That's probably not very efficient.
Yeah. Okay, let's see. You said it was 3308 that you were looking at? No, I must have done that wrong.
Hmm. 3388.
Oh, 3388, okay. 3388. Oh, yeah. Unregistered in-flight.
Although that's basically the structure for all these different things. That's partly why. And there's some op history is 1%. Yeah, I think there's still some improvement that can be done in the op tracker. Make it more efficient here.
Whenever you're ready to be done with that thread, we have a thread 49 on 3717. We can look at.
This is the Blue Store AIO completion thread.
Yeah.
So mostly it's just waiting for IO to complete. That's good. It triggers the deferred completions. There's some contention on that lock. This is about to change, so you can mostly ignore the deferred stuff. The
Okay.
Switches it around. Although I expect we will see some condition there. We should repeat this test after.
Yeah, that was mostly what was there. So we can skip ahead to thread 57 on 3862.
This is the messenger doing its thing.
Yep.
So it's spending half the time waiting, 30% of the time. Percent reading. Fast dispatch is 10%. That's probably worth looking at.
Yeah.
Weighted priority queue. Some of it. Signal 1. I wouldn't expect a P thread con to take any time at all. That's weird. Some allocation here. Op tracker again. It's 1% of the time. Three percent of the time decoding the message.
Mm-hmm.
A bunch of that is calculating a CRC for the message signing. Well, actually, just a verification, I guess.
I think
That's not so bad. It's only 1% is actually spent decoding. What is it? What is 1% decoding, 1% CRC, and a bunch of little bufferless crap.
Yeah, there's throttle, get or fail. I think we were spending about 2% of the time in that.
Is it actually?
2.5.
Ceph. I have a feeling that the perf counter overhead is not insignificant.
Is not significant?
Is not insignificant.
Okay, it's not insignificant. Okay,
yeah.
It's significant.
Yeah. I mean, it's pretty old code, and I don't think it was done super intelligently. It's just a bunch of atomics. But when you're pounding on them from multiple threads, that can be part of it. And I keep seeing this Ceph spin lock unlock, which seems crazy. I don't think we should be doing that. I don't know why that's happening in here. All right, well, there's a whole bunch of stuff here that will probably be whittled away at.
The next big one is 4209 for handle right in async connection. And I promise we're almost to the end.
So 11% of this is spent, 10% in do send message. So nothing's going to change there. And in destructors for bufferless, it looks like. And other bufferless manipulations.
And farther down, yeah, we've got lots of bufferless stuff going on up there, and mallocs and whatever. But farther down, 4328, we have prepare, send message, and we're in encode.
Mm-hmm. 2%
More, yeah.
So encoding the replies is a bunch. That might be worth looking at. I mean, it's not so surprising. This is all asynchronous, so I'm not so worried about it, but it is just burning CPU if we can make it more efficient.
Yeah. Yeah, I mean, a lot of the things that we've kind of looked at with BlueStore have been kind of how to optimize performance in these cases where we have like one or two or maybe four fast devices in one node. But when we get up to lots and lots of fast devices in a node, it's CPU time that really kills us more than anything else.
Yep.
But anyway, that's basically the end of it. So, yay, we got through.
So what are the takeaways here? Take some notes. The things to look at would include up tracker, perf counters, trying to remember what was gross here. BlueFS sync write have an effect on that fsync time.
Mm-hmm. We should revisit deferred finish.
Then lab collections or flat map, etc. on a bunch of stuff. For space map. Where else were we seeing alligator nastiness? Oh, AIO, AOT.
You already wrote down the IO context. Yeah.
That's probably enough to get started.
Yeah, I was going to say fast dispatch if you just want to generically add it to your list.
We need to figure out what is worth looking at there. Oh, sharded upper Q. Why is it taking so much time to signal a condition variable? Okay.
Yeah, but I think all of this stuff is good for us to work on, but I think the big message here is the behavior in RocksDB with compaction.
Oh, period. Action. Okay.
Ooh.
Anything from anyone else? Oh, 2618. That is a good point. Let's see it. 2618. So there is a bunch of code. 2618. So that's okay. So this is freeing IO contacts. This is the list of AIOTs, which also have lists inside them. So that's the AIOT. I don't see CRC here. Let's see. I'm missing something. There is a yeah, so you're right. The only map in buffer raw is a CRC map, and that it's possible that we don't want that actually. We added that when we were trying to mitigate the CRC, the two CRCs that happened during writes. One of them in the messenger when we pull stuff up the wire, and then again in the when we write to the file store journal, we CRC again. And this is on an ARM32. We were doing work for Calzada like 4 years ago. I'm not sure that it's worth having those cache CRCs in the buffer thing anymore. I think it's probably more trouble than it's worth. So, but I don't, that's the invalidate CRC line on CRC, where can I find it? On line 2263. And where else is it? That's the only place I see it. Yeah, so 2618, this deep one, this list in IO context is that what you're looking at, Peter? Because this really deep call chain at 2618 is deleting the list of IO contexts, which I think also has a list inside AIOT, which is a list of something else, and then the buffer list inside the AIOT, which does, the buffer list has a list of pointers and, oh, I see, yeah, you're right, but it's 0.25, so 2638. So that's the CRC one right there. That's only a few sample points, that's not too bad. But yeah, I think we could kill. My suspicion is that we should just rip out that CRC caching thing. It's complicated, and I'm not sure it's helping. And I don't know if I trust it anyway. So yeah, but I would welcome a pull request that does that, especially if it comes with a test that shows that it makes a difference. So yeah, put that on the list. Remove buffer cache map. Okay. Anything else?
Sage, I'm just copying out the 4 megabyte trace, and I'll throw it in here. We don't have to discuss it today, but I thought I'd let you know. I'll throw it in the Etherpad here. That's the only one I really had out of that one that really stood out right away was the one thing, the shallow copy issue.
Yeah, and that one I'll look at that today. Cool. That does look like it's a bug. If it's triggering a copy on those, it was 9%. That's what you saw.
Yeah. If you give me a sec here, I can actually send it along and or put it in here, and then you can see it yourself if you want.
Okay. We're basically out of time. Anybody else have anything they want to bring up? All right.
Sounds good.
Sounds good. Thanks, everyone. Have a good Thursday.
Have a good week, guys.
See ya.
Hey, sorry, I got one question.
Yeah.
Right? This is James from Alibaba. Sorry, I didn't show up for a while because I have a business trip back to wherever it is. And recently we got a lot of issues regarding to the XFS stability. and there are several issues, especially regarding to their XFS LID daemon thread, and whenever we have a high IO workload, the XFS LID just get killed for no reason, and it automatically shut down the several OSDs. And right now we got lots of instances in 2 of our clusters. We right now still try to replicate or duplicate the errors and find more clue of why the XFS file system gets shut down.
It gets shut down, or you just see high CPU time in that thread?
The XFS ID, the daemon thread get killed, and the CPU node is pretty high comparing to the normal IO. Normally, we have a 32 CPU cores. Normally, it's going to shoot up to like 20 CPU cores.
Yeah, I don't know. I don't know enough about XFS to know exactly what that thread is doing or why it might get killed. I wouldn't expect it to ever get killed, honestly, because it's a kernel thread, right? I'm not sure. I would look at the XFS list or in the XFS IRC channel and see what they say.
Okay. I'm also going to write a report and probably send to you guys today.
Oh, cool. Okay.
What we found. XFS issues. Okay, cool.
Cool. Sounds good. All right.
And besides, we recently merged several. We recently right now work on the recovery, and there are several patches already in community. We are right now working on, and we have several data, especially performance data regarding to the asynchronous recovery and the partial recovery.
Okay, is this based on Josh's patch, or is it the earlier version of the patch that you guys had worked on?
It's based on, we kind of merge lots of versions. One is Justin's, the Yaoling's from NetEase, and also one from Howmet's team from XSky. Okay. And the performance get a lot of improvement, and also we figured lots of bugs out as well, especially for their OMAP and attributes issues. And I was wondering whether we can have a talk maybe in next performance meeting and share with us.
Sure. Yep. And if you can post a pull request with the patches before that, Josh can take a look. That would be helpful too, I think.
Sure.
Oh, Josh is here. I'm not sure how close is the branch that you're working on, Josh?
It's only some more debugging, but it's relatively close for the branch that allows you to force backfill. The async recovery bit needs a bit more debugging and fixing up of the recovery path still.
Okay.
Okay, we're going to put together whatever we already done and send to Saj and Josh, and let's see how it goes, because we also have performance data in our production cluster, and then let's see. Okay.
Yeah, that's great. I'll be happy to take a look.
Sure. Thank you.
Cool. Sounds great. All right.
Thank you.
Thanks, everyone.
Have a good day, guys.
Thanks. See you guys.